This is Origin Stories, the Leakey Foundation podcast. I'm Meredith Johnson. We have a very special episode for you today, celebrating an iconic fossil discovery. But before we get started, I'm asking for your support. The Leakey Foundation is a nonprofit, and we're supported by donors just like you. If you care about human origins research, and if you love this show, please make a tax-deductible donation right now. The end of the year is the most important time for nonprofits, and we really need your support. If you give by December 31st, your donation will be quadruple matched. That means your $25 donation becomes $100 for science and science education like this. And the next discovery you hear about on our show will have happened because of you. Click the link in your show notes or go to leakeyfoundation.org/donate right now to quadruple your impact. Now, here's our story. On the morning of November 24th, 1974, a young paleoanthropologist named Don Johanson and his graduate student, Tom Gray, were in the Afar region of Ethiopia. They were searching for fossils when they found something that forever changed our understanding of human evolution. A fossilized skeleton of a small female who lived 3.2 million years ago. To me, she's like gravity or DNA, a discovery that shows us a whole new way to see the world and our place in it. And she's an idea that can be shared in one simple word: Lucy. Today on the show, we're celebrating the 50th anniversary of one of the most extraordinary scientific discoveries ever made. And we'll hear her origin story from the person who made that discovery.
I'm Don Johanson, a professor of anthropology and paleoanthropology at Arizona State University and founding director of the Institute of Human Origins.
Thank you for joining me for Origin Stories.
Well, it's a pleasure. I'd love to talk about Lucy.
Today, Don Johanson is a famous figure with a storied career. He's a multiple-time Leakey Foundation grantee, and his work changed everything we thought we knew about the origin of our species. But like all of us, he was once just a kid, curious about the world around him.
I was interested ever since I was a elementary student in Hartford, Connecticut, and had a wonderful science teacher, Mr. Julian, who was an enthusiast and really got people excited about the scientific method. So this was even before I got to high school. I became particularly interested in biology. I loved wandering the woods near our house and watching rabbits in the springtime and collecting butterflies and so on. But it wasn't until I was around 13 when I read a book called Man's Place in Nature that got me specifically interested in human origins.
That book, written by Thomas Huxley and published in 1863, was the first book devoted to the topic of human evolution. Not the typical kind of reading to capture the interest of 13-year-old boys. Don read it in one evening, and he was hooked. He studied anthropology in college and went to grad school at the University of Chicago. In 1970, he got the chance to join a research project in the Omo River Valley in Ethiopia. He spent 3 field seasons there, doing archaeological surveys and excavations. Soon after, he went to Paris to collect data for his dissertation on chimpanzee teeth. And there, he met a young geologist named Maurice Taeb, who was working on his own dissertation about the geology of Ethiopia's Awash River basin. Don told him about the work he had done and the fossils their team had found in the Omo Valley.
Maurice was full of enthusiasm and excitement, and he thought, if you find the fossils in Omo, you need to come with me to the Afar. He said the Afar was filled with fossils, and he invited me to join him on an exploratory expedition, specifically to look for sites that might be good places to find remains of early human ancestors. So in the spring of 1972, a very small group of us, just 4 of us, went off for several weeks And I was absolutely dazzled. There were places that were very fossil-rich. One in particular, which is called Hadar. I remember very clearly driving up to the edge of this cliff in 1972 in April and looking down into these geological deposits. And the next morning when we drove down there, I was overwhelmed with the completeness of the fossils. The fossils we found in the Omo were very fragmentary because they were laid down in ancient rivers, much like the Omo River that's there today. And those animals would be moved about and rolled about and broken up. In the Afar and at Hadar in particular, it was obvious from the start that we were dealing with lake sediments that were calmer, and that animals that died and were kind enough to fall into those depositional environments would be preserved fairly well and fairly complete. So you'd see partial skeletons of antelopes and gazelles and complete elephant skull with the jaw attached to it.
A great thing about fossil animals like elephants and pigs is that they can help you estimate the age of the sites and the sediments where they're found. And what they saw through the fossils from the calm lake sediments of Hadar was a time period that was especially exciting to someone hoping to find human fossils.
So you could look at the pig teeth or the elephant teeth, and you could estimate that these were well over 3 million years in age. And that was such an important period of time that from which we knew very, very little. And I suspected that this might be a darn good place to look.
So in the fall of 1973, Don, Maurice Taeb, and a small group of others went back to Hadar. They set up camp on a low bluff overlooking the Awash River. The camp was basic and practical. They had one large tent for doing their science and eating their meals, and they had mosquito nets to sleep under.
And I had occasion in late October to find a partial knee. We had the bottom end of the thigh bone or femur and the top end of the shin bone or the tibia. And we now know that that came from deposits that were 3.4 million years in age. And we didn't know who it was. We didn't know what species it belonged to or if it was perhaps a new species.
In the early 70s, Ethiopia didn't have the paleoanthropology labs and dedicated infrastructure they have now. So Don, with permission from the government, brought the mystery bones back to Cleveland, Ohio, where he was teaching at the time.
One of the first people I showed them to was an orthopedic surgeon. And he looked at it and he said, "This is just like the knee that we put in when we replace a human knee. But it's so tiny," he said. And it was very small. But it was the first fossil hominid found in the Afar region. And that's very special to me. I'm mostly known for my discovery of the Lucy skeleton, of course. But that was the great moment of verification that my sort of anticipation had been really rewarded, because that particular time period had yielded very few fossils in Eastern Africa. And I was hopeful that we would find a lot more.
When Don found that knee fossil in 1973, a time I'll call before Lucy, the time period of around 3 million years ago was like a black box. We didn't know much of anything about the human story of that time.
We didn't know much beyond 2.5 million years. And at that time, the oldest fossils came from South Africa and were called Australopithecus africanus, after Dart's Tong baby that was published in 1925. And so that by default became the last common ancestor. To our own genus, we belong in the genus Homo, and also for a group of descendants who were called robust Australopithecus. These are things like Nutcracker Man from Olduvai Gorge or Australopithecus robustus from South Africa. It was a very simple tree. There were about 7 different species. Today, we have over 20 different species. They're not all agreed upon by everyone, but somewhere between 20 and 25 species are on the human family tree.
So let's talk about when you found Lucy. Can you remember that day vividly?
Oh, I remember it exactly. It was a Sunday morning, and November 24th of this year happens to be a Sunday also, so it'll be the 50th anniversary. And I was out with one of my graduate students, Tom Gray, and he needed to map the precise position of discoveries that had been made in that area in the previous year. I wasn't particularly interested that morning in going out, although, you always feel positive that you're going to find something. So I certainly said, well, if I don't go out, maybe I'll rue the day I didn't. So we went out and surveyed in the area where a beautiful pig skull was found the year before. Some people say, why do you call it beautiful? Well, to a paleontologist, a complete pig skull like this is beautiful. And it was noontime, and we were heading back to our Land Rover, thinking of taking a swim in the Awash River, which was nearby, and cooling down and having a little lunch. And a glint caught my eye. I looked over my right shoulder and saw a little piece that looked clearly like part of the elbow, the top end of one of the forearm bones, which is called the ulna, the one that allows you to flex and extend your arm. I kneeled down, began to examine it more closely, and saw that it had to be from a hominid. It just had to be. It didn't have the characteristic little anatomy on the back of it that you would have if it were a primate, like a baboon, which there were many in these fossil deposits. It wasn't an antelope. It wasn't a gazelle. And as we looked at the area nearby, we saw that there were other bones, and some of them were recognizable. There were a couple of pieces of skull, and we saw a chunk of jaw with some teeth in it. I had been studying chimpanzee teeth for a long time, and I could see immediately that these were hominid teeth. But it was a very small mandible, and I said, maybe this is the kind of creature that gave us the knee joint in 1973.
As Don and Tom Gray continued to look around, they realized that what they had was a partial skeleton of some kind of small hominin. They didn't know how much more was there, but it looked like there was more. They excitedly but carefully collected a few pieces to take back to camp.
When we brought it back to camp, everybody was just overwhelmed and thrilled that we had made a discovery as important as this, or as I thought was going to be as important. And the bones were very small, and I thought it was from a female because in the genus Australopithecus, all species show a significant size difference between males and females, which is called sexual dimorphism. And if this was a male, the females would be minuscule, so it wasn't logical. The logical inference was that this had to be from a female early hominid, and we celebrated that evening. We were listening to a Beatles tape, Sgt. Pepper's Lonely Hearts Club Band, and Lucy and This Guy with Diamonds was playing, and Pam Alderman, who was on the expedition, suggested, well, if you really think it's a female, why don't you call her Lucy? And I thought to myself, I've just gotten my PhD at the University of Chicago, and I'm a scientist, and we have to come up with a scientific name. And it really didn't strike me until breakfast, when we were sitting around and people would say, oh, are you going back to the Lucy site? Do you think you'll find more of Lucy's skull? How old do you think Lucy? And you could not change that. If you had sat around and said, what nickname should we give this? You wouldn't come up with something. But it was just serendipity. It was almost like a throwaway. Well, why don't you just call her Lucy? And we did. And 50 years later, she's known as Lucy.
Lucy herself was utterly mind-boggling. beautiful. Over the next several weeks, Don and the team recovered more and more of Lucy, eventually finding 40% of a complete skeleton. In the science tent at camp, the team sorted and carefully laid out the bones, assembling an astonishing creature that was not even 3.5 feet tall, with a tiny brain, some teeth that were primitive and ape-like, and some teeth that were more human-like. And even more amazing, her leg bones and pelvic bones pointed to upright walking, a combination of traits scientists thought impossible at the time. She was like us, but not like us.
These fossils were a distinctly different kind of human than had ever been seen before. And that meant that we needed to redo the geometry of the human family tree, and it had a major impact on the study of paleoanthropology.
Word about Lucy got out before the team even left the field. The Ethiopian Ministry of Culture learned of the discovery, and representatives quickly came to the site.
And they brought with them reporters, and they wrote about her. So people knew that this partial skeleton had been discovered. Word spread very quickly throughout the not only scientific community, but throughout the popular community who were interested in ask that question all the time, where did I come from?
Don and the team returned from the field in 1975 and brought Lucy temporarily to be studied in Don's lab at the Cleveland Museum of Natural History, where he was a curator. He assembled a team and they got to work, trying to solve the puzzle that was Lucy. Getting solid dates, describing the bones, and also going back to Hadar to see if there were more of her kind to be found.
In 1975, we found a collection of fossils, a little bit older than Lucy, like 100,000 years or something like that, where you've got males and females and children and, articulated foot and an articulated hand, and really gave us an insight into the fact that, one, they certainly lived in groups, and these were multi-male, multi-female groups, and for some reason they all perished at the same time. We don't know why to this day, but they did. They weren't taken by carnivores. There are no carnivore tooth marks on these bones. It was not a flash flood, but we don't know why what has come to be called the first family was there. But we had developed this incredible insight into the anatomy of these creatures.
In 1978, with the additional fossils from 13 individuals of the first family, they published a paper in the journal Science describing Lucy's species, which they put in the genus Australopithecus and named Australopithecus afarensis, after the Afar region and the Afar people. The popular press picked up the story, and Lucy was everywhere. And even with all the other fossils they found in 1975, it's Lucy who became a worldwide sensation. It's Lucy whose story endures and who resonates with people in a way science stories rarely do.
She's also known by an Ethiopian name, which is wonderful. It's Dinkinesh, which means you are wonderful. The Afar people in the region where we found her call her Halomali, which is also you are wonderful. And people have frequently asked, why do you think she is so iconic? And why has she become the touchstone for paleoanthropology? You pick up, your morning newspaper, and a new discovery has been made in Kenya or Tanzania or wherever. It's always older or younger than Lucy, or more complete than Lucy, or less complete than Lucy, or not quite as ape-like as Lucy was, and so on. And I think it's because people identify her as an individual, as a person, as someone who actually did live and walk that landscape 3.2 million years ago. They see her as almost somewhat familiar, even though she's exceedingly different from us and belongs to a different species. It's hard to trace your roots back to 3.2 million years ago, But ultimately, she became very important in helping us understand the family tree from a significantly different perspective. But I think that people really relate to her as a person.
With Lucy's icon status, Don also quickly became a science celebrity, which took him by surprise.
It was, in fact, totally unanticipated. It's not something that we're taught in graduate school. Sometimes there's even opposition to people who popularize science. My late friend Carl Sagan, of course, suffered from that. He never became a member of the National Academy of Sciences because he had been on the Johnny Carson show. And I'll remember one of the first lectures I ever gave.
I'm proud to tell you, friends, that this first public lecture was a Leakey Foundation lecture. Mary Leakey was supposed to be the speaker that evening, but she couldn't make it. Don took her place, which was pretty intimidating for him, or really anyone.
And got up there and didn't know how to talk to an audience. I could certainly talk about the biomechanics of the knee and so on, but to bring it into the vernacular where it became interesting even to the non-expert really took me some time to develop. So I found out from doing some of these early lectures that I enjoyed it because so many people are interested in their origins. I mean, it's probably the first question we ask as children. You know, Mommy, where did I come from? We want to know that. And this was where did we come from writ large. And I have continued to write popular books and hosted a 3-part television show in the 90s and built a major institute at Arizona State University and continue to find it one of the exhilarating endeavors in science.
In the 5 decades since Lucy, the science of human origins has evolved quickly. Much more evidence of Lucy's species has been found all across Africa. We're learning a lot about Australopithecus afarensis, even if people still think of the species as just Lucy. Researchers have now found remains from more than 300 Australopithecus afarensis individuals across Ethiopia, Kenya, and Tanzania. And the species is thought to have lived from around 4 million years ago right up until around 3 million years ago.
Lucy is certainly one of the real diadems in the crown of paleoanthropology. Sometimes we just use Lucy as an example for ease of communication. But the species, it's a species that has to be taken as a whole. The species extends chronologically for close to 1 million years. So we know that this was a very adaptable species. They adapted to different environments, and for nearly 1 million years was not significantly changed. So it was a very enduring species. We as Homo sapiens have been around for a couple of 100,000, maybe 300,000. I think that's stretching it a bit, but for a couple of 100,000 years as we are today. But Lucy's species was around for close to 1 million.
50 years after her discovery, there are still exciting questions to explore about Lucy and her long-lived species, even questions we haven't yet thought of. And with new tools, new perspectives, and new ideas, human origin science keeps finding new ways to ask and answer those questions.
It's hard to say, but 50 years ago is quite a long time. So it's wonderful to have lived this long, to see the impact of this discovery. And we haven't mined all of the information from these fossils. And it's so important for people who want to become a paleoanthropologist to understand that it's not just a discovery-based science. There are a lot of innovations in techniques and a lot of rethinking in the theoretical framework, lots to learn about the kinds of environments in which these creatures lived. Why at Hadar, for example, is there only one species of human for 500,000 years. Yet you go maybe 50 miles to the north, there's another site that has Afarensis in it, but it has probably 2 or 3 other species of hominids. And why should that be? And that's a question that many people are really thinking hard about. I think at the moment we're looking at a period of time where there are more well-trained specialists, development of new techniques, new theoretical approaches, where paleoanthropology is on the verge of making some really significant major leaps in understanding our past. We're looking at a time, I think, when we're going to get a deeper understanding of what the forces were, the environment, the climatic changes, the payoffs that natural selection worked on to bring us along to where we are today. I think we're developing a much broader and rewarding understanding of that big question. How did we become human? I'm anxious to see where we go from here.
Thank you to Don Johanson for sharing his story and his work. The Leakey Foundation is extremely proud to have supported Don Johanson's work over the years with 8 research grants, including one during the expedition where he found Lucy in 1974. Check your show notes to learn more about the 50th anniversary, the many new things we're learning about Lucy and her species, and the great work that's happening at the Institute of Human Origins at Arizona State University. Origin Stories is a project of the Leakey Foundation, a nonprofit dedicated to funding human origins research and sharing discoveries. If you want to be part of the next big discovery like Lucy, please join us. All donations through December 31st will be quadruple matched by our Board of Trustees and the Anna Gordon Getty Foundation. Click the link in your show notes or go to leakeyfoundation.org/donate to turn your $25 into $100 for research and science education. Today's episode is sponsored by the Lace family and is dedicated to George Lace in honor of his many contributions as a board member of the Leakey Foundation since 2017. George is dedicated to scientific literacy and education, and he loves the science of human origins. We're grateful to George and to Diane, Donna, Art, and Joe Lace for sponsoring this special episode in his honor. Origin Stories is made possible by listeners like you, with additional support from Jeanne Newman, the Joan and Arnold Travis Education Fund, and the Ann and Gordon Getty Foundation. This episode was produced by me, Meredith Johnson, and Ray Pang. Sound design by Ray Pang. Our editor is Audrey Quinn. The interview with Don Johanson was recorded in San Francisco at Women's Audio Mission. We'll be back in December to share our annual roundup of the top discoveries from this year in human origins research. Thanks for listening.